23 knots, 2,200 meters visibility. That's about a little over 7,000 feet of visibility. That's about 1.3 miles. Light rain showers in the area, a few clouds at 1,200 feet, scattered at 18, and a few cumulonimbus at 3,000 feet, overcast at 8,000 feet. At the METAR at 0630, the winds were reported at 030 degrees at 11 knots, gusting to 21. Looking at just the steady state component of 11 knots, landing on runway 14, that gives us a tailwind component of only 3.76 knots. Now, this aircraft landed 15 minutes later, and the winds were steadily increasing. At 0700, 15 minutes after they landed, the winds were reported at 020 at 13 knots. Let's fix the runway heading here. 020 at 13 knots, giving a tailwind component, steady state, 6.5 knots. 11 knots of crosswind component. At 0730, the winds were up to 20 knots, 020 at 20 knots, giving a tailwind component of 10 knots right up to the limit. And or if you factor in any of the gust factors, which is not required, you can see that at 20 knots, they are at their maximum tailwind limit. Now let's take a look at the Jeppesen plates for Mumbai. First thing we always look at is the date, 14 June 13, and this is an out-of-date Jeppesen plate for training purposes only. Up here in the upper left, we see the airport elevation is 39 feet. And here's runway 14. Looks like a whopping 9,419 feet at first glance. But it looks like there's a bit of a displaced threshold on this end of the runway and another displaced threshold on the opposite end of the runway. The touchdown zone elevation on the approach end is 39 feet above sea level. The touchdown zone elevation on the opposite end is 25 feet, so a slight, very slight downslope to that runway. Now let's look at the other side of this page, the 10-9A page. Roll down here to runway 14, and we see the lighting for the runway. We see that it's got a PAPI that's got a 3-degree glide slope and RVR. There's nothing on here that indicates that the runway is grooved. I'll show you an example of that in a minute. But here is some very important stuff. Landing distance, usable landing lengths beyond the threshold is only 8,106 feet, and usable landing length beyond the glide slope, the normal point where you touch down, is only 7,048 feet. So you've lost nearly 2,400 feet of your original 9,419 feet shown here. Because the objective is you have to land beyond this displaced threshold, and if you're following the glide slope, you're going to land slightly beyond, at or beyond the glide slope point. This displaced threshold is because there's some form of obstacles off the end of the runway. Could be these trees and tanks out here that prevent you from using this very end of the runway. If the runway in Mumbai was grooved, it would be shown on the 10-9A page right down here, like in this example for Hayden, Colorado, next to the runway description. Now let's take a look at the Google satellite maps view of Mumbai and the airport, surrounded by congestion. Runway 14. Here we see the displaced threshold. There's the numbers for 14. And here on the approach end, quite a bit of black rubber deposits right here in the landing zone. As we get to the departure end of the runway, where this aircraft slid off, there's another large amount of rubber deposits left behind by landing aircraft. And at the far end of the departure end of runway 14 is the Mithi River, very close to the end of the runway. Ground-based vehicles like the Blanco Lirio Mobile Command Post has vertical grooves and siping to help channel the water off to the side. Aircraft tires do not have siphoning because they would simply wear out too quickly. Each airplane tire needs to go at least 300 landings. By the way, airplane tires are filled with nitrogen and not air. Dry nitrogen. The reported visibility at the time that this crew landed was 2,200 meters. If we look at the ILS runway 14, and I had to look this one up, CMV visibility, converted MET visibility, minimum is 2,200 meters. So if in the event that the ALS was out, they would be effectively operating right at minimums. If the full approach lighting system was in and the runway visual range transmissometers working correctly, this visibility could be further reduced to 1,400 meters. The bigger point being that this approach was close to minimums, minimum weather requirements, the minimum visibility needed to see the runway. Remember, the third form of hydroplaning is reverted rubber. This occurs under heavy braking where the temperatures of the tires become so extreme that the water turns to steam and the hot steam reverts the rubber back to its natural form, melting the rubber, greatly hampering braking effectiveness. And that's what you're looking at in this video. Besides the water being kicked up by the full reverse thrust, you're also seeing steam from the reverted rubber hydroplaning action.